Hello, my name is Tim Terrell. I'm the owner of Terrell Electric here in Columbia, Missouri. Master electrician, HVAC technician, and plumber. Uh, would like to briefly discuss something here that the City of Columbia has passed. It is Appendix U, solar ready requirements for homes. We'll discuss a little bit about this and tell you a little bit about how all this stuff will make sense for you. Let me emphasize and preface this. I believe in renewable energy. I believe in smart, common sense factors, but I believe in renewable energies, and I believe there's a way to do things that will benefit you more so than out of your pocketbook or out of your conscience. So, what this is requirements here that the main electrical service panel should have reserved space to allow installation of a dual pole circuit breaker and shall be labeled for future solar electric use. Reserved space shall be positioned at the opposite end from the input feeder location or main. It also says that we shall have 2 conduits which can be run on the outside of the house or on the inside of the house in the wall. Well, let's discuss that for a minute. A lot of these jackhammers out here are going to bid this work and they're going to do this work, and then they're going to have some apprentice or some journeyman who doesn't know his butt from apple butter, and they're going to run PVC. Well, PVC is only good for 50 degrees Celsius or 122 degrees Fahrenheit. Trust me, folks, your attics gets a lot hotter than that in the summer. I've been in them, and you don't want that. It's going to cause a problem, and it could also cause a fire in your attic. The last place in the world you want a fire. Speaking of that, put smoke detectors in your attic, people. So, how can we make this affordable, beneficial for you, good for the city, good for the environment, good for everybody around? We can all hug and feel like we're doing our part. Here's the deal. A solar hot water system will cost you between $6,000 and $10,000 depending upon what all you do with it. And I preface that with do with it because you can do so much with a solar hot water system that you cannot do with a solar PV system. Now, solar hot water, you can run the conduit down the wall or pipe, since it's plumbing, inside a wall, put out your stub outs, make your connections in the attic. You can run it in hard pipe if it makes you feel froggy. You could run it in PEX. You could run it in soft copper. You're pretty much at your whim because the temperature of the water coming out of there is about 150 to 180, depending upon, and I'm sorry, the glycol, the antifreeze, because it doesn't evaporate out. So you can heat this stuff up pretty hot and keep everything going, and you can have it inside these pipes and be safe. Whereas with electricity, you have to worry about a couple of issues. One, ambient temperature. If it gets above 122 degrees, you can't use PVC. You really can't use EMT or rigid because of Faraday's law. Faraday's law is a law of physics that states that steel exposed to DC current, which is what's going to be coming off your roof, is direct current. And this is a process called DC degradation or decomposition, and some people will even call it trying to think what it was called. I didn't write it down and I can't think of it right now. But anyway, Faraday's law states that metal loss of 9.1 grams iron per milliamp per year. What's a milliamp? Well, for 20 amps of electricity, it's about 20 million amps, or 20 million milliamps. So you just take that 9.1 times a million, and that's how much iron you're going to lose out of your steel in a year. So then you're going to end up with all this rust, and you're going to end up with these pop marks and stuff like that. And that sucker is going to get so flexible for steel pipe to be flexible and malleable. That's a really weird experience. So I don't really think that's wise. DC current will have electrons, the same as in with AC current. Only the difference is that with AC, you have an up and a flow and a direct current straight through. So you're going to have this ionization charging on your steel surface, on your ferrous metal. You need to have a non-ferrous metal there. Non-ferrous would be aluminum, which you could use an aluminum rigid conduit, but see, it's got iron in it. You're going to lose your iron content, and it's going to start breaking it down. It's also going to get extremely hot because of that interaction going on between and this is Eli the Iceman, between the conductance of your DC current on your conductor and your metal pipe. Now, a lot of people are like, what in the hell are you talking about, Tim? Look, it comes down to this. You've got wood, insulation, and other combustible materials in the wall and in the attic. And you are putting materials together that has a law, a physics law, Faraday's law, saying, hey, that's a bad idea, because you have inductance between the DC current and the steel or iron, ferrous metals, inside the conduit. And you can't use PVC because it's not rated for over 122 degrees Fahrenheit. So that really makes photovoltaic not a suitable option. I like solar, and I love solar PV, but you've got to think about it. What's in the best interest of your house? You don't want your house catching on fire while your children are asleep. You're trying to do this for your protection, stuff like that. Now, there's a lot of solar panels out there that are mounted. A lot of people doing it a lot of different ways. Me, I'm a master electrician. I don't leave nothing to chance, and your safety is far more important than my pocketbook. I will not install something that is not code compliant, and I won't make the excuse, that's the way we've always done it. You deserve better than an excuse. Now, let's talk about solar hot water for a second here. For $6,000 to $10,000, you can put a solar hot water system in. And this is, you get a really good return on investment. And let's speak again about return on investment with solar PV. The average household uses 1,500 kilowatts of electricity per month, kilowatt hours. And at 8 cents a kilowatt hour, that's $120 a month. You can say, okay, I'm below average or I'm a little bit above average, but the average is about $120 a month. Now, 1 kilowatt system, a 1 kilowatt PV system will generate 850 kilowatt hours per year. 850 kilowatt hours per year. So if you look at 1,500 kilowatt hours per month, 18,000 kilowatts per year, and you're going to generate 850 for $25,000, you're generating 4.7% of your usage. It's going to take you 370 years to see a return on your investment. I'm just saying. Something to think about. Now, how can you see a better or a greater return on your investment? Well, you can do solar hot water. Now, solar hot water, let's look at it. You have that $8,000 to $10,000 or $6,000 to $10,000 price range on that. Well, how much does it cost on your utility bill? Heating your home and heating your hot water. Those are the two biggest elements on your heating, on your electric bill. If you run an electric hot water tank and electric heater. Your biggest is your heater, Okay, so your annual cost for a natural gas heating system at 80% efficiency is $1,215 a year average. If you're 92% efficient, a high efficiency furnace, you're at $1,095 per year. If you use propane, hold on to your shorts, folks. 80%, you're spending $3,143 a year on average. You need to replace that one. If you do a 92% propane tank, that is a whopping $2,632 per year. Again, you need to change it, because in 4 years' time you will have paid the installation and the furnace off from going from propane to natural gas. You need to get off propane, folks. Now, in electric heat pump that is a 6.65 efficiency, you'll spend $1,284 a year. That's a little bit more than natural gas, but it's not that bad. A heat pump at a 7.5% efficient is going to be $1,135 per year. Again, you're about $500 more than the natural gas one, but you're in that ballpark. So now let's look at the hot water tank. Hot water tanks are going to account for 14 to 18% of your electric bill if you're on electric. If you're running gas, it's going to account for anywhere from 9 to 12%, 9 to 14%. If you're running propane, it is ungodly. It is about $350 to $700 a year to heat your water from that. So you're looking at about $30, $40 a month on your hot water tank to heat it. So let's look at this. If you put $10,000 into a solar hot water system, one, you're going to have 400 gallons of hot water a day to use. I mean, goodness, it's going to do it. Two, if you put a radiator inside your furnace above the A coil there inside that air chamber, you can just blow your air over that heat pump, over that radiator part, and circulate water through it, and that spatial air will be heated up. Now, what's the effect of that? Okay, so right now your furnace kicks on when it's 50 degrees outside, and it starts heating up your house. If you do this with a solar hot water system and put a radiator in your box above your A coil, and you just let your fan blow. Just let your fan blow. It's not going to be 10 cents a day. It's nothing huge. You let that blow across your radiator in there. Now your furnace won't kick on until it's about 20 degrees outside, because that is heating up your house, that spatial heat. Now, in Missouri, I don't know about the other states, but in Missouri and across that timeline there, I would just say that our average temperature in the winter falls between 50 and 20 degrees Celsius or 20 degrees Fahrenheit. So if you are taking care of 80% of our temperature, now granted, we're going to have our cold days where it gets negative 20. Oh my God, it's there. It can happen. All right. But for the most part, our winters are between 50 and 20 degrees. That's where we stay at. So if you can accommodate that heat where your furnace is only kicking on when it's the really cold days, you've now reduced your electric bill. Now let's look at the numbers here. So we said that your electric heating bill for your furnace was going to cost you about $1,150. That's with a heat pump. Let's do it with a natural gas unit. So you're going to be at $1,095, $1,100 a year. Okay. Now you put that in there and you reduce it by 80%. Go ahead. You're looking at almost saving yourself $800 on that. And let's just say that it's, it's the 60%. You're still saving $600. And you did a $6,000 install. It pays for itself inside of 10 years. Okay, but that's just one thing. That's just one thing. Now your hot water. So now we're going to heat up the hot water. Okay, and we figured it was $30, $40 a month just with propane. Okay, so now you got that for free. So now you're putting $630 to $10,000. You bought a $20,000 car. You're making $500 a month payments for 5 years. This is already giving you $634 back on your intake there. You're ahead of the game. The numbers don't lie. Now, if you build your house, you can do solar radiant floor heat. Run a lateral through there, put it in a garage, have a heated garage in the wintertime, run it through your sidewalks and your driveways. You never have to shovel. You'll never have to worry about ice. Dig a pool, run it in your pool. You'll have a heated pool in the wintertime. We do come out of the wall, down the wall, make yourself a little clothing, a towel rack in your bathroom. While you're taking a shower, it's heating up your towel for you. It is endless what you can do with solar hot water. You can have so many features and so many things. You could heat up your ground so that you have green grass year round. If you want to do it, you can do it. It's the sun heating it. It's fine. Use it. It's free. It's renewable. You put that sodium glycol in there and let it go. Let it go. Forget about it. You'll be fine. Use a drain back system so that it doesn't freeze up, split up your unit up on the top side on your roof, anything like that. Have it drain back into your tank. Run 2 taco pumps off onto it. You're good to go. It's a very simple, easy system. And you can run all that in hard pipe. You can put all that inside your walls. You can make it a very nice, neat, clean, easy breezy, very, very nice installation without having to worry about a whole lot of things. The city of Columbia is doing this, and it's just more legislation, it's more regulation, it's more problems. I get it. I like renewable energy. I'm all about renewable energy. But I think that every person needs to be smart with it. I think it needs to be wise. And the city knows that it's not wise. That's why they're not doing any incentives. They're not doing anything to promote it other than making it a law. Think about that for a second, folks. If you're really behind it, you really support it, do something about it. It's something to think about. But remember this, you can't run PVC conduit in your attic. Your attic will reach temperatures of 195 degrees. When it's 95, 96 degrees outside, it's 196 in your attic on average. And PVC can only go to 122 degrees, folks. It gets weak, it breaks down, and it starts having problems. And it bakes those conductors inside there. Inside of it, it's just baking them. So now they're going to melt together, fuse, you'll have a short, you'll have a fire. It's bad. And this is another reason why I say put smoke detectors in your attic. If you have 5 smoke detectors and one's in your attic and it goes off and it's sequenced in with everybody else's, you know where the problem is. You have 3 hours basically to get the fire department there to put out the fire before you lose property. Get everybody out of the house, call the fire department, take care of it. It'll save your life. It'll save your property. That's all for me. I'm sorry for the length of this. Say good night to you. Have a great day. Again, Tim Terrell with Terrell Electric. We're here for your renewable energy edification, knowledge, and experience. We are your power integrity experts, and we are here to see that you are safe, that you are happy, and that you are never billed high prices for your electrical service.